So in this video, we're going to talk about how to complete a quadratic polynomial so that it becomes a perfect square trinomial. So I got to remind you what that is, okay? And these are the preliminaries to a method called completing the square that allows us to solve quadratic equations. Okay, so let's remind ourselves what a perfect square trinomial is. Okay, so these are the trinomials that we get when we square a binomial. For example, if I square x plus 5 and I multiply this out, I get x squared plus 10x plus 25, as you know. And we've discussed previously that the first term of a perfect square trinomial will be a perfect square. This will be a square, this first term. And that the last term will also be a square. And that whatever was squared to get these two terms, so for example, in this case, the x was squared to get x squared, and the 5 was squared to get 25. That when you multiply those two together, the x times the 5, and you double that, then you get this middle term of 10x. So double twice 5 times x will give you the 10x, right? Okay, so let's do one more. 2x plus 3 squared. Okay, so again, if you FOIL this out, you're going to get 4x squared. So notice that, again, this first term in your trinomial is a perfect square, and you got it by squaring the original 2x, right? And then in the middle, you're going to get, well, the outers are going to give you 6x, and the inners are going to give you another 6x. So you're going to get 12x, which was double 2x times 3, which were the two original terms in the binomial over here, right? Okay, and then finally, the last will be 9. So again, the first term is a squared, was 2x. The last term is a squared. Over here is 2x squared. This is 3 squared. And the middle term can be figured out by multiplying the 2x times the 3, which is 6x, and then doubling it. And there's your 12. Okay, so why are we going through all of that review? Well, because now I'm going to give you the first two terms of the perfect square trinomial. So for example, I might give you the x squared plus 10x, and I want you to come up with the 25, which is the third term that would complete that square. Luckily for us, there is a way to do that. There's a method. So I'm going to show you that method now. Okay. All right. So here's example number 1, which says complete the squared. So notice I'm giving you the x squared minus 12x, which are the first two terms of the perfect square trinomial we want to build, right? And so again, what do you know? Well, this guy is a square, the x squared. What did we square to get that? Okay, x. And then I know that whatever I add here, it's going to have to be a square. Some number squared, right? Perfect square. And that whatever I squared to get this guy times the 2x doubled should give me the negative 12. So first of all, think of what did we double to get a negative 12? Well, we doubled a negative 6x, right? So then that means that here's the x is already there. So that means that this guy must be negative 6 squared. Okay, so how do we get that? So again, this middle term, which you remember that's our b, And let me remind you, ax squared plus bx plus c is our quadratic polynomial in standard form. So the coefficient of the x term, we're calling that the b. Well, we know that this guy is double what we multiplied from these two, right? The double of what was in the binomial when we squared it. So to get this third term, then we know that we're going to have to take half of b. Okay, and that's how we got the -6. And then we square that, and that gives us 36. So the perfect square trinomial that we were building is x squared minus 12x plus 36. Okay, so what if I asked you, how does that factor? Then which binomial did you square to get the perfect square trinomial? And if you said x minus 6, then you're right. Okay, look at the next one. So this next one is a binomial z squared plus 13z. And again, we are looking for the last term, the constant, right? The c, right? Because remember, it's ax squared plus bx plus c. So we're looking for what would make this guy, what could we add here so that this trinomial would be a perfect square? Okay, so we're going to take the same idea as we did last time. All right, and last time we knew that this middle term, this b, was double what we needed, right? So this is what we're going to do. We're going to take half of the 13. Okay, so we're going to take 13 over 2. Because that's half of 13, right? And then we're going to square that just the way we did over here with this -6, right? We squared that to get the 36. Well, here we're going to square 13 over 2. And so that gives us 169 over 4. And that's our c. That's what's missing here. So the perfect square would be z squared plus 13z. And then our constant term would be 169 fourths. And how would that factor? Well, z plus, and then whatever, remember, whatever we squared to get 169 fourths is what goes here. So that would be 13 over 2. See what I mean? Okay, so I'm coming up to this box because that's what this box tells you to do. It says, to complete the square of x squared plus bx. So notice that we have a plain x squared here, that the leading coefficient of x squared is 1. A equals 1. Because if you think that it might be a little bit harder if there's an a here, then you're right. And we're going to be doing that later, okay? But when this leading coefficient is 1, then we are to complete the square, to form the perfect square trinomial, we are going to look at b. And what we're going to do, okay, so we're going to look at b. And what we're going to do is we're going to take half of that middle coefficient, half of b, and then we're going to square that, and that's going to be that's what's going to come here. It'll be our constant. See what I mean? And then how will it factor? X plus b over 2 squared. So whatever we squared to get the x squared, which was x, goes here. And whatever we squared to get the last term goes here, the b over 2, half of b. Okay, I know this can be hard if you've never seen it before, but trust me, you're going to get it. Okay, let's look at the number 3 here. T squared plus 18/7 t. Okay, again, this coefficient is 1t, so that means we're going to look at just that. That's our b. So b equals 18/7, and we need half of b. So multiply half times 18/7, which of course I see some reducing here. I'm going to do that right now. 2 goes into here once, into here 9 times. Okay, and then we're going to square that. Square 9/7, right? Multiply straight across. Square that is 81/49. So that's what we're going to add. We're going to add the 81/49. And our new perfect square is trinomial is t squared plus 18/7 t plus 81/49. And how does it factor? It factors as t plus whatever you squared to get 81/49, which is 9/7. That's what goes right there. Okay.